Uh, Hello everyone. Today we are going to talk about routing fundamentals and OSPF. We'll start with the basics of routing, with static routing and default routing, then we'll move on to OSPF. Okay, so what's a routing table? Routing table is like, if you remember, in switches, they have a MAC address table, right? That's how they are mapping the interface they're mapping the port interface with the MAC address of the PC, like right. That's how they are identifying where to send the packet, right? So the same concept with the routing happens, but in a routing case they're using IP. Okay, the IP of the next interface or the next router. That's the routing table. It decides where to send the packet based on the routing table. So we have two most important concepts in a routing table: connected and local routes. Okay, let me show you here in practical, so we can see. So there is one command we can use: show IP routes. Remember, this command is very important because this is how you can actually see the routing table. Right now there is nothing, right? The reason is because I didn't configure any IP address on this ports yet. Let's configure the IP address and then we'll check again. So config t and f1.0 IP address 192.168.2. So let's do it again. Do show IP route. Yeah, as you can see now, it's showing me the routes, right? It's showing the connected routes are 192.168.1.0 network, this network, and here 192.168.20. This network, right? This is what it's telling me. The connected routes are the routes that are connected to this interface, and this is L, which is the local routes. Okay, which is the ports, the IP of the interface on the router. See this one? This is the local route. This is 192.168.1.10, and this one is 2.1 here. This is the local route. And that's what we need to know for now. This is the connected and this is the local route. And yeah, and you see how I identified the connected route and the local route. There's a letter for each routing protocol, and for each it will appear here on this side. So for example, if we have when we configure OSPF, this one, or it will be O. Okay, IA or OIA will be like inter-area, like for multi-area OSPF configuration. So basically that's the key things. Static, if I configure a static route now, it will be S. These are the things that we need to know in OSPF here. And we have to know the mask and the destination is so this is C is the connected, L is for local, and static is for OSPF is O. So what else we need to know about this is let's configure static route. Okay, or let's just see here, and since we already configured one second, close this one. Let's configure static route, but first let's try to see what's the IP of this PC. Yeah, it's not showing actually. It's not showing active. start. R1P. No, so let's just close it and let's try to console here now. Give it some time. Hello? Yes. Okay, let's continue. Let's open the PC1. Okay, 1 second. PC1 is not showing here. Actually, for static route and default route, you can also configure it on packet tracer. Okay, let's just configure packet tracer. For advanced configuration, we're going to use this this GNS3. Okay, let's just remove. 1 second. This is the configuration. So let's try to do the configuration now. Enable. So I'm going to use the same configuration here, 192.168.2.1.2. Okay, so I'll put this one 1 and this 2, and here it's going to be 192.168.1.1 and 2, this network. And here it's going to be 192.168.3.1.2. So basically this is it. Config T and G00, G01. So and G00 here, IP address 192.168.2.1, 255 to 255 to 255.0 is the IP address, and no shut interface G01, IP address 1.1. Yeah, I put no shut here, right? No shut. Yeah, so let's configure this side as well. No. No. Enable config T. So G00, G01 and G00, IP address 192.168.2.2, 255.255.255.0, no shut. Interface G01, IP address 3.1, 3.1, and no shut. shit. 192.168. Already in use, so let's try to configure this one. .1 192.168.2.1 and yeah, the IP is used actually. I'm using the routers 3.2 here, 192.168.3.1. Okay, so let's configure the. Let me show you something now. Okay, assume like first let's make sure that the configuration is actually good. The IP configuration is correct. To show IP interface brief. So G00 is .210.21, yeah, and G01 is 111. Let's configure. Make sure this is 01. Yeah, correct. So here to show IP interface brief. G00 is 22, okay, and G01 is 31. Let's make sure G00 is 22. Yes, correct. So this is done. We already configured the IP as well. So let's try to ping. This is .2, right? So this one is .3.2. So let's try to configure this one. Ping 192.168.3.2. It's telling me destination host unreachable. Okay, because still we didn't configure any routing table. So this router doesn't know where 3.2 PC is located. It only knows where this network and this network. It doesn't know this network yet, right? That's the purpose of configuring routing here, so that it can access the other networks, right? Now if I try to ping, let's say I want to ping 2.2, this port, this network, again can't access this one. Let's try to ping 2.1. It already it can ping, you see, because already this router knows the connected network, okay, but it doesn't know this network. So let's configure the static route to make it see the other network. Config T. Yeah, we're in config T. So to configure static route, we use IP route. This is the command actually. IP route. We configure it on the global config mode. IP route. Then the destination address. Yeah, which network we want to access exactly. Don't remember this point. Let me show you. See the destination prefix. That means this one. We want to access 192.168.3.0 network, and we are going to use the prefix 255.255.255.0. Okay. And then we have to add the interface from which we have to tell it the route. It will go from here, right? 192.168.3.0. 2.2. Done. Do show IP route. So this is the route 192. See, S static route is represented by S. So now static configuration is done. But even now, if we try to ping from this PC to this PC, it's not going to work. There is a reason why. I will tell you after. Let's try now. No, this is because we are pinging 2.1, right? Let's try to ping 3.2. Actually, let's make it continuous ping. Let's use /t. So, yeah. Request timed out. Right? Now, you can like try it yourself and try to understand why this is happening. The main reason this is happening is because we only configured a route on this router. Okay, it's sending the packet, but it doesn't know how. It's not coming back to this network. So this router also doesn't know about this network. You know, so we have to configure a static route here as well for this router to see this network. So exit IP route. So we'll put 192.168.1.0 255.255.255.0, and then it's going to go through this one 192.168.2.1, right? Let's see what's the issue here. Because I put 2 dots here. So now let's wait and see the ping. It's working, as you can see here. Now it's coming back because we are sending it and it's coming back again, the packet. So now this is how we configure the static route, IP route, the destination network, then the interface that it's going to go from to. This is how static route is configured. Now let's move on to default route. Okay, let's just remove this route. Okay, we removed it here, and let's remove it here. Remove it here. Okay, so now I just removed the static route, right? So what's the default route? Default route is like, instead of defining the IP at the destination IP address, we just leave it zeros. Okay, any network. Okay, and we define the interface. So anything that comes out from this, send it to this. Let me show you IP route. Yeah, 0 0 0, whatever. Yeah, 0 0 0, whatever you want to send. Okay, send it to 192.168.2.2. Done. Okay, do show IP route. As you can see now, this is its symbol is S, but asterisk. They put asterisk on the top. So this is basically how default route works. This configures. Basically, we don't we don't know where we want to send this traffic, this packet, right? So we don't define the destination IP address. We just leave it at 0, which means any network, and then we define the IP where to the interface. Okay, let's configure it here as well. IP route 0.0.0 0.0.0, and then 192.168.1.1 .2.1. So now it should, as you can see now, we're getting and receiving the replies. Right? Now it's working, so default route is configured. So basically these are the two things that we need to know. Also there is one more thing that you need to know. Show IP route. So as you can see here now, Yeah. So how does router makes forwarding decision? Okay, this is an important topic that we have to know actually. AD, we will get back to it. Metric compare. Yeah. Prefix length. Yeah. So how does a router makes forwarding decision? Okay, router choose the most specific route first. Okay, what does this mean? It means like this. Which is more specific? This now, this /32 or /24? /32 is more specific because /32 is like only one network, right? 3.1. But here, 24 is like 256 networks, 256 devices, hosts, right? So this is more specific. So if we have like same and same, if we have two networks, okay, it's going to select the most specific network. If you have two identical networks, it's going to choose the most specific one route first. This one, like for example here, 10.0.0.0 to 16 and 10.0 to 20.0. So this will win, right? This is more specific because this is not specific at all. Prefix length beats everything else. If prefix length is equal, okay, let's say they have the same prefix, which is /24/24, and then what will happen? Static wins, because then it will see the administrative distance. We have something called administrative distance. Each routing protocol has an administrative distance. Okay, what's administrative distance? The trust level of the routing protocol. So lower AD always win. Lower administrative distance always wins. Okay, the lowest, the more it win. For example, connected is 0. Okay, so this is the device that are connected has the lowest. Static route it's 1. Okay, OSPF is 110. Okay, EIGRP is 90. Rep is this. This you have to memorize. Okay, you just have to know that administrative. Like for example, if you configure it OSPF EIGRP into the same router, okay, it's going to prefer, and same network also, it's going to prefer this one, the OSPF, because it has the, no, it's going to prefer EIGRP because it has the lowest administrative distance, right? So yeah, you can think of AD as a trust level. Lower AD always wins. Okay, so this one perfect, yeah. And AD1, yeah, if for example you go, yeah, you see static versus OSPF, the same prefix length, static wins. Okay, because it has AD1. Routing protocol metrics, if they have the same prefix, okay, and they have the same active AD, okay, the same protocol, okay, then the lowest metric wins. This is the last this you have to remember, lowest metric wins. And yeah, so we have 3. You check, yeah. So there are 2 types: route to a network routes. This is yeah, this is what this is how we configured. If you remember, I used 192.168.2.0, right? Like this, I used this way to configure the static route. This is called the network route. Okay, but if I want to go only to one specific device, I can use this one, host route, 10.2.10. This to this, and to go to this one, right? Specific route. I'm using /32. 255.255.255. Yeah, used for servers, VPNs. Floating status, backup route with higher AD. Okay, this backup route, all else fails, with higher AD. Prepare the component of a routing table. This already we've talked about. Prefix, destination, next hop. Next hop is this one. See, it's telling you via 192, right? It's telling you how to get where via, yeah, where AD metric. This is metric. Host inside. OSPF uses host as metric. Okay, every routing protocol uses different metrics, but OSPF uses host. OSPF is like this. It uses 110 over 2. AD is equals to metric is 2. This is the metric, the second line. We are going to we're going to go through it when we go. The default route. Default route is this one that we configured here. This is the gateway of last resort. Like if all else fails, it's just going to use this one. So the default order. The order is critical. The longest prefix, this is what we discussed, and administrative distance, routing protocol, this is how it makes the default route. And so that's about it for routing fundamentals. Okay, now we will go to the more advanced concept, which is OSPF. Talk about theory and then we'll configure one lab. Okay, so this is important. OSPF link state protocol builds a complete network map and uses Dijkstra SPF algorithm to calculate the shortest path. Administrative is 110. This is what I told you, right? Classless supports VLCM and route summarization. Okay, we discussed this in the previous session. Fast convergence only sends updates when topology changes. See this one? This is very important. It only updates when there is a change in topology. Okay, so let's talk about how OSPF works. It discovers neighbors with hello packets. It sends hello packets. For example, if we configure OSPF here and this router, it's going to send hello packets, okay, to discover the neighbors. Okay, then it will exchange a link state advertisement. Think of it like messages. It exchanges messages between them, right? Build identical link state database in each area. You got me? Link state database is basically it's like a database with information about each routing information for each routing table, right? Here we have one LSDB. Here we have one LSDB. Run SPF algorithm on LSDB. Install best routing table. So these are the key things we need to know. All areas must connect to area 0. Area 0 is like the main area, the backbone. Okay, so for example, if I configure this two router, this one of this has, if I have multiple routers here, okay, it doesn't matter how much, right? There has to be an area 0. All has to be connected to area 0, which is the main area, right? Here single area OSPF, all routers and area 0 simple network. Okay, and ABR multi-area, let's say we have more than one area, okay, which is for large network. ABR connects area 0 to other area. Okay, for routers to become neighbors, they must match these things. Okay, in order for a router to become like for these two routers to become neighbors, okay, they have to have the same area ID. Okay, like for example, if I'm going to configure here area 0, here also has to be area 0. If I put here area 0 and I put here area 1, it's not going to work. Hello dead time timer, like how often to send hello packets and dead timers. This also has to match network type. Like for example, you can't configure this this configuration like point to point with this broadcast or this something else, right? It has to be the same. Authentication type, or if you configure authentication, it has to match. MTU sometimes. So basically this things has to match in order for neighbors to form. So these are the neighbor states. Okay, this you will see it when on the console, on the logs. Let's say the OSPF, the neighborship is down. Okay, you'll see down. Then initialize. Initialize means they will start exchanging, initializing 2 ways. Two-way means it will like one router will send to this router. Okay, two-way means it will return the them. Okay, X start, then exchange, then they'll exchange, then to go to loading state, then full. Okay, these are the neighboring states. DR and BDR, election broadcast network. Election process highest OSPF priority, which is the default equals to 1. Yeah. DR and BDR. First of all, let's understand what's DR and BDR. Okay. DR means, let's say you have like 3-4 routers. Okay. Like OSPF uses broadcast, so it will keep sending to all. If you don't have one master router or superior router, it will keep sending the LSAs to all, flooding the network, right? But since if you configure one strong router here, for example, let's say we configure a good router here, okay, and we connect all here, so this router has to be the DR, the main router, because this router may have more memory, more CPU, stronger router. So all the LSAs will go to this router, and this will send to the other routers. Okay. Instead of sending to each other the LSAs, they will send to the DR, and the DR will handle all the load. Okay. How can you make this router, for example, a DR? Okay. You can configure it OSPF priority, the highest priority. The default is 1. Okay, 0 means it's never going to be DR or BDR. Okay, for example, these two routers are very weak. You don't want them to be a DR or BDR, right? You can configure. You can put the priority 0 here, priority 0 here. You put the priority on this interface that's connected to this routers, 200 on each interface. Then this will be the DR. Okay, BDR is like a backup. Okay, so it reduces LSA flooding on the internet. BDR form full adjacencies with all routers. So that's basically the main concept of DR. Okay, router ID or ID selection order. So how is RID selection order? See, RID selection order manually configured. Okay, router ID, we have one. Okay, so router ID selection order. It will choose the manually configured router ID. It's actually recommended to configure manual router ID manually for each. For example, here I will configure router ID 1111. Yep, and the highest loopback, then highest active physical interface IP. Always configure RID manually using loopback interfaces. So it's recommended to configure RID manually. Okay, this is the router ID. But for more details on router ID, we can refer back to this one. It's a unique identifier, highest loopback. Okay, how it's automatically configured. It takes the highest loopback. If highest loopback IP is greater than highest physical IP, and then highest loopback IP it will choose. Okay. Then if it is the same, then highest physical IP, then manual router ID. Selection and troubleshooting. Not actually confident about the router ID. 1 second. Let's just router ID OSPF. So it's a unique 32-bit identifier in router represented in IP as an IP address, never discovery DR and BDR. Typically chosen as the highest IP on the loopback or physical interface. not manually set. So this is what I'm saying. If you don't set it manually, okay, OSPF uses the highest IP address on any configured loopback interface. If there is no loopback interface exists, it uses the highest IP address of any active, like this one, interface. So prevents duplicate reads from becoming neighbors. Designated used for as a tiebreaker. If multiple routers have the same highest priority, it can be used as a tiebreaker. Okay, and HLSA carries read in the advertisement. So that's basically it. Link state advertisement. LSA describes topology flooded in to build identical LSDB per area. So what's we said that LSA is like a message that each router sends to each other, right? And yeah, LSDB is a database of this information, right? Describes a topology flooded to build identical LSDB per area. Okay, the LSDB should be same in an area. The database. So if this and this are both on the same router, on the same area, they should have the same LSDB. Okay, that's the main benefit of OSPF also, right? So in static routes, I as I showed you, I had to configure the IP manually here. Okay, I had to configure it here as well, and I would have to configure it here as well for each network. Okay, static route is okay for small network, but for large network, OSPF is beneficial because you don't have to manually configure anything. It will automatically share the LSDB or link state database and sync it. All router will have the same, in the same area will have the same routing table. Okay, so key types, high level. So just a link state advertisement. What you need to know is like type 1. Okay, let's go back to our main notes. So metrics, we said that cost equals to reference bandwidth over interface bandwidths. Okay, so default reference bandwidth is 100 Mbps. Actually, this is for all the default bandwidth, right? Lower cost equals to better path. Okay, so 100 Mbps Ethernet cost equals to 100 divided 100 equals to 1. 10 Mbps Ethernet cost 10. It's for 2 methods. Okay, yeah. Actually, this is what we need to know about reference bandwidth. It's like the interface bandwidth. It's like, for example, if you have a good quality cable or network like fiber or something, you can set it. You can set the reference bandwidth. You can set the reference bandwidth. Okay, and higher reference bandwidth, so it will choose that path. Okay, like the configuration is actually with me here. 1 second. Yeah, this is the configuration actually. Auto cost reference bandwidth 10,000. Okay, I'm configuring this for each router actually. For each router, because manually this is recommended to configure this manually, because it will choose. If we don't do this, it will automatically default to 100, which is not correct actually. Make the cost calculation wrong. Okay, this is best practice to set it manually. And what more we have here? Configuration 2 methods. Traditional, yeah, there are 2 methods of configuration. This is the configuration IP OSPF 1. Okay, this is the process ID. It doesn't have to match on either routers, right? You can put here 1 process ID, the other router 2, 3, it doesn't matter. Just an identifier, process identifier. Here, network 10.0.0, 0.0.25, area 0. here is like I'm using wildcard mask. This is called wildcard mask. Yeah. So yeah, I'm area 0. See, and passive interface gigabit 0/1. This is a configuration. This is done so that remember I told you this this router, for example, if you configure both the routers, all these routers now, okay, in OSPF and put them in area 0, okay, what will happen to this routers, to this LAN, right? Router will be able to send the hello packets, the LSA and all this stuff, yeah, to this network as well, right? But this network doesn't need all this details, right? It's just going to send it unnecessarily, right? It doesn't need that because this is just a PC and the switch, right? So you can configure passive interface gigabit here, for example. On this interface, you can configure this, make it passive interface, prevent sending traffic, OSPF packets, and to this network, inside the network. There is another way of configuring it. This one inside the interface based IP OSPF, OSPF1 area 0. These are the main verification method. Show IP OSPF neighbors, show IP OSPF interface brief, show IP route OSPF, show IP OSPF database. So there are two network types: broadcast default for internet, for Ethernet, uses DR PDR, okay, and point-to-point serial link, no DR or PDR, faster convergence. Okay, these are the main things that we need to focus on: point-to-point and broadcast. Real-world based, yeah. Always use loopback for router ID. Use passive interface on user configure authentication system. Okay, let's discuss how to configure this topology using we've already talked about configured using static route and default route. Let's use OSPF to make this PC ping this PC, and let's add 192.168. Alright, 1 dot. It's actually the name here, and we have to actually specify the default gateway here, 168.1.1. Valid address. Let's add the subnet mask. Let's see if it will accept invalid. I think it's the issue is this one. We're not supposed to use address on the PCs when we configure it. So this is done. So let's make sure. Yeah, so this is configured correctly. Let's configure this PC as well. 2.168. This is going to be 3.2. 3.2.255.255.255.0. This is fine, but didn't configure the gateway 168.3.1. int f0 over 0, IP address 192.192.168.2.1 5525550 255.255.255.0. No shit. And yeah, let's configure this as well before configuring OSPF. Let's just make sure all the IPs are correct, configured correctly. Config t int f0 IP address 192.168.2.55.0 1 over 0 192 IP address 192.168.3.1 255.255.255.0 192 yeah, to show IP interface brief. تم f0 over 0, this is the IP, and f0 okay, it's administratively down, you see. So int f10, int f10, no shit, no shit. Let's try to show IP int. Yeah, both are up now. Let's try this one. Let's check, just check the IP to show IP int brief. 192.168.2.1 doing that anymore. This is router OSPF 1 int network 192.168.1.0 and 255.255.255.0. This is how we configure the OSPF. Area should be 0, and let's do the .2 network, same area. And there is more configuration that we need to add here, but for now let's just keep it like this, just to check if the OSPF is working or not. R2 and router dot OSPF dot 1 and network dot 192.168.168.2.0 255.255.255.0 area 0 2.0. So let's just have a look now. OSPF never should be conform everything is because I'm advertising all the network .1, .0 and I think I should use the wildcard mask instead of the subnet mask, but doesn't really make a difference because already it's now here on full loading is done. So yeah, now the OSPF is configured. You see, on this means that the OSPF is configured. To confirm, do show IP route. Yeah, this is, as you can see here, we have O, so it's seeing this network. Okay, this router is seeing this network, and let's do here do show IP route, and yeah, it's here. So to confirm, let's try to ping now. This ping should work. PC now, ping 192.168.3.2. Yeah, it's pinging. So now OSPF is configured. طيب تمام. Yeah, now what we will do is, since ping is working, now the ping is working fine here. So now the OSPF is configured. So let's do the extra configuration. First of all, you have to make this one, this interfaces as passive interface. This one, F10, F10, so that doesn't receive the packet. Because let's start with R2 and F1 over 0 IP OSPF. No, we have to. Here we can make like 1 second. It's supposed to be here router OSPF 1. Okay. Here we're supposed to say passive interface and this passive interface, and then the interface which is F1 over 0. Sure. Jig. To show IP and passive interface 0. And R1 here and F1 0. Now let's just put the router OSPF 1 passive interface passive interface F1 over 0. So now remaining is we have to configure the priority on the interface, actually F0 over 0, because I want R1 to be the DR. So I can just configure it using IP OSPF priority 200. Okay, and also I want to configure auto post reference bandwidth 10,000. Yes. And this is changed, so the configuration here is done. Let's do this here as well. Auto post reference bandwidth 10,000 and F0 1. So I'm going to make it OSPF priority priority 0, so it will not be configured. DR configuration. It will not select R2 to be DR. So this is the main configuration. There is one more thing that we forgot to do here. We have to set the OSPF 1, the router ID manually. R2, let's make it 2.2.2.2, and R1, let's make it router ID router ID 1.1. Yeah, so this is how it's configured, but we want to see the verification method, the verification commands. We have 3 commands. Okay, we're going to do it. Let's go to let's check it one by one. This is important. This command, show IP OSPF neighbor, yeah. So we've made R1 full DR address, yeah. So the neighbor is DR. You can see that it's DR from here, right? R1. Okay, R1 is DR. Let's try to do the same command here in R1. Do show IP OSPF neighbor. Yeah, full drother. This is not DR. 3.1 is DR. It's the drother. Expected is, see, this is drother means I think the PDR. It's not DR actually. This is R2. You can see that whether it became DR or no from here, and this is the priority that we set. Okay, and that's it. And let's check the other command, verification command, show IP route OSPF show IP route OSPF. So it gave me only the OSPF route. Okay, and to show IP OSPF interface F0/0. Yeah, this will give me details. Show IP. Over 0. So this is DR. Tamam. Yeah, you can see that it's DR from here, this command as well. State DR, priority here. Remember I told you the hello time and the should be same. The form number should be same. The dead timer also same. 40, and yeah, these are the key things. The cost is 100 here. The cost is 100. So this is how we configure OSPF. Like this, we will conclude our session for OSPF. Tomorrow we will talk more about one more topic in routing that's remaining. That's FHRP.